Good day, scientists, and welcome back to Outdoor School. Thanks for joining me today for our very special creature feature lesson and activity. By the end of our time together today, you will be able to tell me something about the quality and diversity of water by studying the species and the populations of organisms that live in it. You will also upgrade your observation skills to level awesome, and you will have done some super cool scientific drawings. But before we get started, we must gather our science supplies from our outdoor school kits. If your kit is in another room, go ahead and pause the video to go grab it. Once you have it handy, take out your field study notebook, a pencil, crayons, your measuring tape, and your whiteboard and dry erase marker. If anyone does not have access to their science kit today, that's totally okay. Go ahead and find something to write with, like a notebook and a pen. Have y'all ever heard the term field guide? If you have, think about the first time you heard about it. Has anyone seen one in person? And if you have, what was that experience like for you? Other students have shared with me that field guides can be used to identify something or to look something up and find out more cool facts about it. Those students were absolutely right. Field guides are made by scientists and are used by all kinds of folks to do just those things. The cool news is, today, my friends, we are going to practice making our very own field guide pages. Alrighty, so the picture on this slide is of a page from a field guide. Let's take about a minute or two to check it out. If you'd like more time, you can also pause your video. Now, using your whiteboard or piece of paper, write down as many answers as you can for the following questions. What do you notice about the page? What do you notice about the dove on the page? What do you wonder about the dove? What do you wonder about the book that this page is from? What does it all remind you of? And what more do you want to know? Awesome. Thanks for doing that, scientists. Keep your answers handy because we're going to come back to them soon. There are a few key words that we as scientists will need to understand. These may be words that y'all have heard or even used before. The first word is diversity, which means difference or variation. Now, let's break down the word biology. If we cut biology in half, we get bio, which means life. And then we have ology, which means the study of something. All right, now let's look at the word biodiversity. What do you think this word may be referring to? Write down those thoughts on your whiteboard as well. What did y'all write down on your whiteboard? Very cool. So remember how bio equals life and diversity equals different? Well, biodiversity equals the variety of life in the world or in a particular habitat or ecosystem. Having biodiversity, or a variety of life forms in an ecosystem, is super important to the health of that ecosystem and all the different life forms that live within it. Ask yourself, now, why is biodiversity so important? Let's check out the insects in this picture. They are an important part of the ecosystem for more reasons than one. Can you think of one of the reasons why this insect contributes to biodiversity? Biodiversity can be influenced by many different factors. Let's look at a few of these factors together. We're going to take a moment to independently read about the factors that affect biodiversity in a negative way. You can pause your video here if you'd like. If you're not sure where to start reading, you can start where it says habitat loss. To recap, what a lot of these factors have in common is that they result in changes to an ecosystem's plant, soil, water, and food supply. These factors are often caused by the same things like human behavior and influence and result in a lack of biodiversity. Next, we're going to watch a video that tells us about a threat to biodiversity in a body of water right here in Oregon.
Oregon's Crater Lake is the deepest in the country and the centerpiece of a national park. In recent years, the lake's water temperature has been on the rise, and those warmer waters attract crayfish that are now putting the lake's native creatures and clarity at risk. Correspondent Jess Burns of Oregon Public Broadcasting and the environmental public media partnership EarthFix has this report.
Biologist Mark Buchtenica is scouring the shoreline of Crater Lake. Flying ants, lizards, and small toads are everywhere.
Aren't they cute?
But the critter he's looking for is much more elusive. Then his persistence pays off. This is the Mazama newt.
Mazama newt from no place else in the world.
Crater Lake formed nearly 8,000 years ago after Mount Mazama erupted and the caldera began filling with rainwater.
We don't know when newts entered the caldera, but sometime thousands of years ago.
There were no fish or other predators in the newly formed lake, and the Mazama newt expanded and thrived.
It's playing dead on us now.
It was the undisputed top of the food chain, but not anymore. Because crawling beneath the surface of the lake, a new champion has emerged. The signal crayfish. Their story begins more than 100 years ago. To attract visitors, early conservationists began stocking the lake with game fish. Craig Ackerman is park superintendent.
In the past, the national parks have done many things which people thought were good ideas at the time that turned out to be not so great ideas.
In 1915, park managers introduced the signal crayfish to feed those fish.
And that turned out to be a worse decision than stocking the fish in the first place, because the crayfish have become out of control.
And this is obvious out in the lake. Scientists at the park are finding that crayfish and the Mazama newts don't really get along.
We have a standoff. What's going to happen?
Not only do they compete for the same food, but studies done by park biologists show crayfish chase and harass the newts, causing them to flee.
They almost look like they're pack hunting a little.
And in some cases, much worse.
They're virtually the perfect invader. The Mazama newt, on the other hand, is an ideal prey.
After thousands of years evolving without predators, the newt lost its best weapon, a potent neurotoxin that can kill.
With the loss of its toxicity, it's left virtually defenseless.
But actually, crayfish in Crater Lake weren't thought to be such a problem until relatively recently. Surveying started in 2008, and scientists found newts had the advantage, occupying about half the shoreline. The crayfish had most of the rest. By 2014, the crayfish had taken over 75% of the shallows.
It's right here, Scott.
And that's not all, says biologist John Umick.
Got it. Big bags for this one. Crayfish are impacting all the organisms in the nearshore, not only newts. In crayfish areas, we don't find snails. You have to go outside of the crayfish-dominated areas to even find a snail or two. Instead of this great biodiversity area, it's down to one or two organisms, and that's it, besides crayfish.
Without these tiny organisms eating the algae, the crystal blue clarity of Crater Lake could be at risk. Crater Lake biologist Scott Gerdner suspects that climate change is playing a role. The surface temperature of the lake has increased about 3 degrees in the past 10 to 15 years.
And it may just allow the crayfish to move faster. They just are more active at warmer waters. And it may allow them to have more success at reproduction so that their numbers have increased faster now.
Scientists expect that if crayfish continue to spread,
it's very possible that the Mazama newt would be eliminated from the lake if we didn't do anything.
But at this point, no one knows exactly what to do. Trapping, even intensive trapping, hasn't made a dent. Yet there are a few glimmers of hope for the Mazama newt. There's the possibility of building underwater barriers or fences to slow crayfish expansion. Another solution could be provided by the lake itself. Spring-fed pools like this emerge when avalanches pile up rock berms along the shore. These pools are newt nurseries. controlling the signal crayfish and protecting this unique ecosystem will be labor-intensive and expensive.
But the Park Service's mission and mandate is to do this above all else. So we will put the resources into this that we feel necessary.
The sobering reality is crayfish will likely never be eliminated from Crater Lake.
Come on now, guy.
And maybe the best the national park can hope to do is carve out a few safe havens for the Mazama newt.
Thanks for watching that video with me, friends. I'd like for you to open your field study notebook to page 11 or use your paper from your notebook to answer the questions seen here. What was the impact of humans introducing the crayfish to the lake? Did this aid in biodiversity or cause biodiversity loss? Awesome job so far, y'all. You are truly doing so great. Now it's time for the fun part, our creature feature activity. Below is a list of species that are often found in the natural waterways in the forests around Portland. I want y'all to choose one of the creatures on this list and create a specific field guide entry in your notebook on page 9 or 12 to 13. If you do not have your field study notebook, feel free to use a piece of scrap paper, line paper, or a different notebook. Pause the video here to take at least 5 minutes to do some research about your creature and learn as much as you can about it before you do your entry. I'll meet you back here when 5 minutes has passed. Ready, set, research. Welcome back. Check out this page and even pause the video if you'd like to make sure you included all of these in your entry. Now, scientists, I'd like to see accuracy in your drawing. This creature should look like what you saw in your research. And remember, if you have more colors at home, you can use those too. For a real challenge, y'all can use your ruler to try making your drawing to scale. Awesome work, scientists. I cannot wait to see these field guide entries. When you are done with your entry, go to page 11 of your science notebook or use the back of your paper to answer the questions you see here, the best you can. You guys did incredible today, and I'm so proud of your science skills. It is now time for us to part ways for the day, but before I let you go, I wanted to say thank you for your hard work and participation. Now goodbye and go be great.